Good afternoon everybody and welcome to a session on engineering graphics. I am Mr. Yash Chawla from Parul Institute of Engineering and Technology, Vadodara. We are going to discuss a few basic introduction of engineering graphics. Why is it important for each and every single branch of engineering? We have a misconception that it is just for civil and mechanical, and we are going to clear out that misconception today. Apart from that, we are going to discuss loci of points very briefly. So moving on, what are we going to talk about today? Engineering graphics is a very wide subject and it cannot be summarized in just 1 hour. So we have to select a particular section which we are going to discuss today. So we are going to answer a few questions. Why is it important for all the branches of engineering? We are going to discuss a few drawing instruments and accessories, uses of plane scales, representation of factors, and then loci of points with a slight introduction, and the locus. What is a locus? So the first step, introduction to engineering graphics, the language of all engineers. What is engineering graphics? Now, for understanding engineering graphics, we should first know what is basically drawing. Now there are two types of drawings. One is an artistic drawing, other one is a technical drawing. Now if I'm an artist, I see an object and I just fell in love with it and I'll draw it on paper. But I will not take care of the perspectives, I will not take care of dimensions, I will just make it as and how I want. But a technical person will interpret it otherwise. An artistic person won't care about any points of similarities between that original structure or the original object and what he is drawing on paper. But a technical person has to take care of what it is, because whatever he is drawing on paper has to be interpreted to become an object by a production engineer or whoever is interpreting that drawing. So let's take a look at an example. This is an artistic structure. These are cars, these are mechanical objects, these are designed by a freehand artist. But no engineer in the world can predict what is the height of the car, what is the length of the car, what type of tires are going to be used, what engine is there. No specifications are there. What we are using in this, no specifications are there. So now this is an engineering drawing. As we can see on top, the height of the object is given, the width of the object is given. This is the front view, this is the rear view, and when we look at it from the side, this is the length of the car again. This is the top view of the car, where again the width is mentioned and the length is mentioned, the length of the windows are mentioned, the front is mentioned. Everything is particularly specific. So if I want to know what type of car it is, I can interpret it by design that it's a sport car, it's a low-lying car, and I can interpret what kind of fluid dynamics it's going to create. Another example, this is an artistic structure. It does not have any specifications. On the contrary, again, see, if you interpret this object from the front, it looks something like this. Whereas if you look at it from the top, from here, it will interpret something like this. Whereas if you look at it from the side, it will be something like this. Now you can see there is a similarity between this object and this object. This is because it is a square, and the top view as well as the side view both are same. And you can see the diameters of the circles are given, the length and the width of the sections are given. So if I am an engineer and I want to make this object a reality with any material, I know what type of specifications are there, what width I have to cut, what circles I have to drill, what holes I have to drill. Everything is particularly specific. So I will be clear that if a person sitting in US has done this drawing, I don't need his or her presentation to me that how should I build this structure, because I particularly know that this is what I have to make and these are the specifications with what I have to make. Moving on. Now the most important question of all. When we teach engineering graphics to first year students, they always ask us, especially CS electronic students, that sir, why are we learning this kind of drawings? Their perspective or their point of view is that it is just for civil and mechanical. Well, look at the photograph. Civil and mechanical, true. Primary requirement for engineering graphics. This is a machinery. This is designed in Pro E, a 3D structure with all colorings and everything denoting different parts of the object. In the background you can see that there are a few drawings of the different views of the same object. Now, on the other hand, this is a house designed by a civil engineer or say an architect. He needs to be specific to give these designs to whoever the contractor is going to build this structure, because he should know what thickness of the wall should be, what height the wall should be, what beams, what columns should be, what is the distance between them. Everything should be very clear. Or if I am a structural engineer, I need to design this structure, then I can design this structure in a soft copy, and then I can use it to analyze what kind of forces, what kind of stress, and what everything are getting on the particular structure. Well, is the perspective of the students right? Well, check out this drawing. Now this is a DC motor, and this on the other hand is an electronic circuit. Well, you can see it is very colorful, it is very bright, but it is not just any drawing which has been laid out by any engineer. It is being made by an electronics engineer. This is a circuit particularly showing what commands or what will be the flow of electrons in the circuit to produce any particular functions. See, these different lines interpret different flows. The red interprets high flow of electrons, blue interprets less flow of electrons. And this, you can see the section here, this has been enlarged here. So this is another scale of the drawing. This is 1:1 scale, whereas this is an enlarged scale. So these are all interpretations of engineering drawing which are being used by a electronics engineer. So it is important for an electronic engineer. Well, moving on, for electrical engineers, all the power plant layouts, the piping engineer might do it, but the electrical wires, from where they have to pass, what kind of turbine they are going to use, what will be the generator capacity, what will be the design of the generator, everything has to be interpreted by an electrical engineer. So it is important for an electrical engineer. Moreover, if I am an electrical engineer and have to pass transmission lines from the power station to the substation and to the houses, I need to lay out the geographic lines from where my towers stand, what type of wires am I going to use, from what will be the length of the wires, what will be the distance between the two poles. It is not decided by a mechanical engineer. It can be decided by a mechanical engineer, but to give freedom to an electrical engineer that it becomes an own specialized field, we teach this subject to electrical engineers. Well, now comes the point of CS and IT. Why are they learning? This is a simple flow chart, but this simple flow chart, if it is drawn correctly with proper shapes, can interpret a whole process. Different blocks have different interpretations, and all these are part of engineering drawing. If you don't know what kind of line you are going to draw, what kind of shape you are going to draw, how can you draw? Moreover, the new branches that are coming up in CS and IT, or computer science, engineering and information technology, one of the branches is digital image processing. What is an image? It is a drawing. If you cannot know what is an arc, how can you make computer interpret that arc? Because you itself don't know. So it is very important for you to know something, then only you can make the you can make the PC or the computer know what it is. So it is very important for computer science and information technology students as well. Well, let us discuss an example. Maruti and Suzuki. These are two different companies from two different nations which speak two different languages, but yet they have a very, very nice and years back relationship. Today also we buy Maruti Suzuki cars and they are running good. But have you asked a question? What happens when a Japanese engineer who does not speak English or does not speak Hindi make a design? How does an Indian engineer who speaks only Hindi or English interpret it? If he says something in Japanese, something like this, wah, wah, I didn't understand a damn thing. But that guy must be understanding what he said. He might have said an arc or a circle in his own language, and if I say a circle, he might not be knowing English, so he won't be able to interpret it. But if I draw a circle and I mention it is 20 centimeters in radius, I don't have to say what is radius, I just have to mark it on the figure. If he draws that figure and sends it to me, I know what he wants. He wants me to draw a circle or make a component which is 20 mm in radius and it is circular in shape, because shape and size on paper don't have any language. It has its own language which can be interpreted by anyone in this world. So Maruti and Suzuki have a very fine combination, and we Indians are getting benefited by it, as well as their technology is getting to us, and we are able to exchange our technology with them. So what did you observe? What are the conclusions of why engineering drawing or engineering graphics is important for all the branches of engineering? Well, it breaks the language barriers. The first and the foremost important thing. There are many different languages in India itself. If a engineer in South is designing a drawing and he uses his own local language, a Gujarat student who just knows Gujarati won't be able to interpret it, because he'll be writing in his own language, Kannada. Or I'll be writing in Gujarati, he won't be able to interpret what I am writing, su che, kam che, right? So it breaks the language barriers. There eradicates miscommunication. If I want to say 10 mm, 10 mm is a standard everywhere in the world. Not even in India, it's there in the world. If I am saying 10 mm, an engineer sitting in US will know what is 10 mm. He has that particular scale. So there is no point of miscommunication, and the accuracy as well as precision is very high, because there won't be any mistakes in interpretation. So what does it result in? It results in global technical outreach and mutual development. We buy MiGs from Russia, but do you know that is a Russian design, designed by a Russian engineer who does not speak English? How Indian engineers are able to maintain it if I don't know what is the design? I cannot just open the aircraft, $1 billion aircraft, and just open it and just say, oh shit, I am not able to assemble it because I don't know what is there, what is written in the guiding manual, because it is in Russian. But if he gives us an assembly drawing, if he gives us the drawing of different parts, I know which part is going to fit in which. So it is very loud and clear to me that if I am disassembling a part, how can I assemble it back? It is there in the assembly drawing. So drawings and engineering graphic make up any engineering field. If you don't know engineering graphics, you cannot be an engineer. Well, this is what graphics are. But how do the graphics come on paper or sheet? We need instruments, we need sheets, we need support for that kind of thing. So we are going to discuss what instruments are we going to use, what is the standard procedure of using those instruments, what are the standard equipments that we use. First of all, we need something to draw. We cannot just draw anything on thin air. So we need a paper. We need standard size paper, because if I draw something on a sheet of say A4 and somebody else is interpreting on A5 on the same dimension, then it might create a problem. You might be able to say, oh, this is small and this is large. Is there a problem? Might be. So that creates miscommunication. So here we have the table. It ranges from A0 to A4. A4 is a standard printout paper that we use. Its dimension in mm and inches are given. I've also shown its comparison with the US scale. You can see that there is in inches for an A4 paper in India, that is Indian Standards Organization has given this particular 8.27 by 11.69, whereas in US the same is denoted by A rather than A4, and its dimension is 8.5 by 11 inches. Now you can see that it varies in millimeters or minute centimeters, but the overall area of the sheet remains almost the same. This is the same thing with A3, A2, A1 and A0 papers. And here we have an extra sheet of paper which is even larger than A0, which is basically used by architects or civil engineers who are laying out the drawings or plans of any house or any towns that they do. So this is very important to know that what kind of sheet should we use for what kind of drawing. Well, if we have sheet, we need to put it somewhere. It cannot be a scribbled place. We don't want to make the sheet dirty, because if it is dirty, then it might be interpreted something else. If I have a dot on the sheet, it might be interpreted as a hole, and that engineer might drill a hole where it is not required. So I don't want that. So I want the sheet to be neat and clean, as well as if I'm drawing a single line and the surface beneath is rough, then my line will be a zigzag instead of a straight line. So I need a plain surface. That is where the drawing board comes in. I have a drawing board of soft wood that is there, on which I can mount my drawing sheet with the clips, just like we mount clips on clothes that we hang on the wires while we keep them for drawing. Well, the speciality of this particular drawing board that we use for engineering drawing, that it has a working edge on the left hand side. Now this working edge has a great deal of importance in engineering drawing. How do we define an horizontal drawing? Well, an horizontal line is an horizontal line. Well, if I draw an inclined line and then I turn my face and see, it becomes an what? It becomes a horizontal line. So I need a reference to draw an horizontal line. So I use this edge as a reference and use my t-square for mentioning what is particular horizontal for this particular sheet. Well, the modern drawing boards come in this particular structure. They have a frame so that the engineer can sit in front of it and then draw it very easily. And previously they used to keep this kind of board in laps and then and it becomes twitchy, but this is a stable structure, so it won't lap from left to right or nap from front to back. So the drawings are more accurate and more neat than the ones which are made on a simple drawing board sitting on a bed with your back arched. Well, the next point, or the next particular instrument, is a drafter. Now this drafter has many specialities. It is a very versatile instrument and can be used for a variety of things. As you can see on the left hand top, that we have the drafter which is mounted on the drawing board that we saw in the previous slide. It has a clip that gets attached to the drawing board, and then the arms can be moved. These arms can be moved to take the scale all over the drawing sheet. Well, this particular scale is at 90 degrees, so we can draw horizontal lines, we can draw vertical lines, and we can draw a perpendicular line to a horizontal or a vertical line. Moreover, the speciality of this particular instrument is that it comes with a 360 degree scale. So if you want to draw an inclined line, say at 30 degrees, we can just mount this particular scale and turn it at 30 degrees on the scale that is given, and then keep it there and draw as many 30 degrees line parallel to each another as we want on the sheet. Moreover, if you want to measure an angle of 45 degrees, then I can keep one of these open and take my reference line and take the angle and mark it here. So simultaneously I can do a lot of things with this particular